Hey everybody, welcome. Thanks for attending our webinar today. We recently launched our most exciting version of Flurry in public preview, as well as our cloud platform. And today, Brian and Andrew are going to take you through some of our new features and functionalities. Brian, I know we have a lot to get through today, so I'll hand it off to you.
Yeah, we sure do. So thanks, Kevin, for kicking us off, and thanks everybody for being on the call. We've got a lot to pack in. We're really excited about this new launch of Flurry. We call it Flurry V3. Some of the enhanced capabilities for those who are used to using Flurry V1 or V2. We'll highlight some of why V3 is certainly a bit different in how it acts, but a really big evolution in capabilities. And then we've also launched a cloud platform where Flurry V3 natively lives and can basically allow you to create and collaborate on data sets in a GitHub sort of like an environment or way. Flurry can still be run, of course, locally in your own cloud, just as a server, but this is a whole new way to experience basically working and collaborating across data sets as well, so they can be used together. Anyway, we probably have a mix of people who are used to working with Flurry and have used Flurry for some time, and then some folks who are newer to Flurry. So we'll try and address both audiences. And one of the things I'd like to start out with is just to give a high-level overview as to why we built what we built and what it is we're looking to accomplish as a company. I'll try and keep this pretty short, and we'll jump into actually seeing some products, which I'm sure will be the more exciting part of what we're about to go through. So presenting today is myself and Andrew Johnson. Andrew will be walking through most of the demo. We'll kind of start out with me once we get into it. But before we kind of get into the pure demo part, we want to talk just for a moment about this notion of collaborative data. What we mean by collaborative data, why we think it's important, and it helps explain the capabilities that we have in Flurry and why they're there. So our view, of course, is that data is becoming more centric to decision making. Things like AI and all of these things are, of course, catalysts, but it's not just AI. Just organizations' ability to make good and better decision relies on good and better data. And we can't just think about data inside of an app. We need to think about data across apps and even data across organizations or even across the world. And that really brings us to this notion of shifting from data kind of being non-collaborative, data traditionally being there just to store state for an application, into data becoming more of the focus than the application itself. And as we see technologies evolving in developing applications, sort of rich single-page application capabilities like we have with Angular and React, what we're seeing is a lessening of dependency on an application server and on the apps themselves. And what's becoming, I think, more of a focus is the experience, how end users interact with information, manipulate information, some enforcement of kind of business policies, of course, within that, but then the data itself becoming super critical to not only be available for that app, but any app. And this notion that eventually apps will come more to the data. And right now, of course, when we buy an app, what we're doing is we're sending data to the app. So the solution, back to this word in collaboration, is that instead of when we need to collaborate around data right now, because the data is really locked behind an app and very specific to that app, either we need to go through an API layer that's been exposed, and of course it has challenges, but certainly is one approach to enabling data. But when we want to rely on that data for things like analytics and combine it with other data, hitting a bunch of APIs and trying to sort of coordinate them doesn't really work real well. So of course we turn here to data lakes, data warehouses, where we're basically copying and pasting data at a moment in time from an app, pasting it into a data lake. But we lose all semantics because the semantics of that data actually sit inside of the app. So now we have a bunch of copies of data. We've lost the data security. We've lost what the data means in that process because the app is holding all of that logic. So then ultimately we have to try to rebuild that logic and then try to normalize our data so that we can actually use our data effectively across all these silos. And so our focus is, a data approach that eliminates a lot of those needs to do those steps, because we're going to natively build semantics into the data itself. And of course, there's tremendous standards out there that have been out there for a long time that provide a real strong roadmap to doing them. And there are things that we've more fully embraced in Flurry V3. So the W3C semantic standards, Flurry is technically a graph database and of the type either semantic graph or knowledge graph, kind of interchangeable terms there. And we focus on and are talking a lot about JSON-LD because we think it makes these types of semantics and technology just a lot more accessible because they're represented in JSON. And most developers know JSON. So traditionally, while these standards and capabilities have been there for a while, they've just been so difficult for people to understand and use. Of course, they're specialists, and we see them a lot in pharmaceutical companies and financial services companies. They have pockets that are real experts in these types of technologies. But as far as general development and a lot of other organizations, we don't see huge adoption. And we actually think this JSON approach to these standards can make a real big difference in enabling more people to sort of understand this and leverage some of the power that comes with it. And then on the right-hand side here, of course, we focus on decentralization. So, I talked about data collaboration and being able to sort of connect data seamlessly. And immediately when we start doing that, we start dealing with issues like, how do I trust data? When I'm browsing in the web, I get my little lock icon in my web browser that basically guarantees that the data hasn't been manipulated, there's no man in the middle, that it has integrity. When systems need to automatically compose and work across data seamlessly, they need those same sorts of protections. And just like cryptography is used kind of behind the scenes as you're browsing the web, you just see that little lock icon. Flurry handles a lot of this cryptography for you, unless you want to get involved with it in the background. So it's not something that has to be kind of in your face. It's just happening there for you to make sure that all the data you're dealing with across your sort of data networks and combining all has trust and integrity. And then, of course, the second thing you start immediately running into is, well, I want to share this data. Certain people should only be able to see certain things. Other people can't see other things, or I might have policy or regulation that comes into play that might make me need to restrict the data in certain ways, depending on how it's being used. And Flurry, of course, answers this in the ability of actually adding programmability into the data layer to enforce policy and permission. And we do this generally with what we would call a data-centric approach. So much of the programmability that we enable can actually just be described using data and data structures. It's not like you need to jump into code and start writing custom apps to be able to do this. And you'll see some of this as we go forward. So I'll quickly summarize this and then we'll get right into that demo. So what is Flurry? We are a graph database. The way you interact with it is through JSON, but we really, unlike, there's other databases you've probably used JSON with, document databases, a MongoDB, et cetera. They usually come with some limitations. And our focus, of course, is adding these 2 extra letters to the end of JSON-LD, which actually adds an immense amount of capability to really look at and provide power in databases that those document databases struggle with. That normally people have to go to a relational database to be able to, normalize or denormalize data in ways that it becomes more reusable, and you have these powerful query capabilities that have immense flexibility. You don't usually get those in a document database, but you do get the ease of working in JSON. I mean, what we're really doing here is giving you not only that ease, but giving you that power, and technically even more power than you would get in a relational database and in data modeling. Embedding data security right into the data layer, which facilitates data sharing more easily. When we talk about collaboration, time starts to become really important, because if I'm trying to coordinate results and data across a network of information or across composing multiple data sets, if every data set is changing with every update and might be changing every second, how can I ever get reproducibility or predictability in the information I'm looking for unless I wield the power of time? So Flurry creates a new database version with every update. Every database version is immediately accessible to any query you want. And when you're trying to lock in things across a network, that becomes important. And of course, it has tremendous value when you want to look at data provenance and data lineage. How has data changed over time, being able to reproduce results, at historical moments in time. So there's a lot of really neat capabilities that come out of time when you have the ability to control it very natively in a database. Of course, decentralization, we talked about this. Being able to compose queries or compose data sets together dynamically instead of having to copy and paste data into a data lake to be able to query across them. And of course, that's just the beginning. You still need to transform them and you lose the security, all the things I talked about before, but really this dynamic composability across real-time data. And a new capability that isn't yet in the sort of platform we're going to show you today, but being able to embed reasoning and inferencing directly into the data set. So whether you're basically putting in rules that are automatically generating features in your data, or you might be using an ontology to be able to automatically create data inferencing, we've got some really exciting capabilities just around the corner to be able to allow you to create even more sort of richness and more capability directly into the data set. So with that, we are at demo time. And what I'm going to do here is instead share my web browser, if I can get to it. All right. Hopefully everyone can see my window here and see where I'm at, which is in data.flur.ee. So anyone can go, we've formally launched this cloud platform. So anyone on this webinar can go and create an account. It's a lot like GitHub. So once you create an account, you kind of establish a namespace. I'm at B Platts. I now own this namespace. And of course, unlike GitHub, which has source code repositories within my account, here I have data sets within my account. So if you don't already have an account here, would certainly encourage you to do so. Andrew and I are going to work a little bit here together. We'll try and keep it efficient because I know we're on a webinar and we have limited time, but we're going to work a little bit on a data set. And I already created a data set in my repository here, and I've labeled it here webinar. I have a little README file, didn't spend a whole lot of time on it. But if I jump into a notebook I created on this data set, I just want to quickly show you some of the data that I have available within here. This notebooks feature is a really cool feature. I can create new notebooks. I can embed, Markdown here and ultimately end up sharing these with other people. In this case, I've created a query that is querying for both invoices and accounts, which is what's in this data set. So if I just execute this query, of course, I'll see the results here of all the invoices within this data set. So this is just JSON data, literally JSON data. And what's cool is that my query result that I'm looking at here is quite literally identical to the JSON data I stuck into this database when I populated it in. So it's JSON in, JSON out. In fact, one thing that I think Andrew will focus a little bit on is the way I'm querying for the data is JSON. It looks just like the data I put on it. It makes it really, really easy to work with. And I'm looking at JSON here. Of course, I could visualize the data as a graph. It is a graph database. Here we're seeing all of the invoices in the data set on the left. You'll see some of the invoices point to the same accounts. And of course, the accounts themselves have additional data. And I have a query, down here. for account-related data. So I want to work with Andrew on this data set. And so the thing I want to do is actually go and add him as a collaborator. So here I'm in the settings, and I'm going to go ahead and see if I can find his account. And there he is. And I have this ability to actually establish a policy for that data set for Andrew. Now, there's just two policies right now in this data set. One called a read all group, which every data set automatically gets, which allows you to read or basically view everything in the data set. You can't modify anything, but you can certainly view anything. And we've already created in this data set a new policy group we call here Flurry internal, and that's going to limit certain types of data that Andrew can see. So I'm going to go ahead and assign him this Flurry internal policy. I could assign him multiple policies, and I'm going to go ahead and add him as a collaborator, and then we'll sort of let him take over from here and see where we get.
So as Brian shares the mic with me and this data set as well, we'll take a quick look at how I immediately have collaboration access on that data set. And then maybe at the end of the demo, we'll come back to it, because I think some of the ways that permission is helpfully managed by the Flurry Cloud Platform's UI gets into a little bit of how the policy itself is data co-resident with the data. And that becomes really powerful, and I think the power of that will be most easily discussed once we take a little bit of a tour through the platform and talk about what's happening under the hood. But to start out, if I go ahead and just share my screen, and I'm going to go to that same Flurry Cloud Platform that Brian was just on, I will, however, I'm now logged in as this Flurry demo account. When I go to data sets from the home screen immediately, what I'll see is that having not created any data sets of my own yet, I actually immediately have access to that same data set that Brian shared. And just to quickly drive the point home so the point's not initially lost, the policy group that Brian gave me doesn't let me see everything in this data set. In fact, it's specifically configured to allow me to see account data, but to hide any invoice data from me. This is just a generic example, but the kinds of ways you could limit data sharing really become, the sky's the limit. If there's a kind of characteristic in your data that would govern, or a characteristic around an identity that could possibly govern access, it's possible in Flurry to write policies and establish policy groups on these data sets so that collaborators, either in the UI or via API keys or with cryptographic identities, find that their access is enforced by those data-centric policies. To show this off really quickly before we take a kind of slower journey into the UI and explore everything that's available, we just saw a second ago Brian issuing these same queries himself. If I come in here and I look for any of that invoice data, which I shouldn't be able to see, I don't even kind of get a redacted view of this. The fact that invoice data exists is in fact invisible to me. Whereas if I come in and query for this account data, I'm able to see all of that account data. So whether this is making it possible to share data inside of an organization, but making sure that folks outside of sales who might want data for analytical reasons don't have access to PII, or whether this is wanting to share your data with the public or with the developer community because you think it could be exciting to them, if you think they could build cool things on top of it, but you also want to be really careful about what they're doing, what they're able to see, obviously what they're able to update, but also if there's pieces of sensitive data or data that you might not want to share with someone unless they've joined as a customer who's paying you for this data. The sky's really the limit on what it looks like once you can start to open up this very granular collaboration around the data sets that you manage and discovery of data that other people are sharing with you. We're going to start, though, just to make sure everyone kind of understands what Flurry is and what the cloud platform itself is. We're going to take a step back and just do a kind of initial walkthrough of creating a data set and looking at all the things that we can start to do with it. Then we'll start to get into some of the things that make Flurry really genuinely unique, not just a database technology that's easy to work with immediately. Oh, well, I tried to access Brian's data sets, so that's a good sign. If I go back to my data sets, Flurry is not just a kind of intuitive JSON expressed database technology, but what makes us unique, as Brian mentioned, is the idea that not only can you easily work with data, but you can genuinely collaborate around data and work with your databases as if they're inclined to sharing first. We think that what makes that possible is, again, both the ability for JSON data to be semantically enriched, to self-describe itself across machine systems, to multiple applications, to be commonly understood when multiple people are writing that data, but also the kinds of guarantees you need around that data once you're not the only person writing to it. So things like cryptographic trust, things like immutability. When those are in place, it becomes legitimately possible to collaborate around data, to have data that's produced by multiple machines and human entities, consumed by multiple machines and human entities, virtualized across multiple data sets at a time. And so hopefully by the end of the demo, we'll get to a point where we can gesture at what makes those things possible and how to do those things inside of the UI itself. So we'll start with just my webinar data set here. I won't spend too much time filling out any details here that'll go into the README, because we're going to really just dive in straight to the data itself. The moment that I appear on the kind of landing page for this data set, we'll see that we're brought to an initial quick start notebook. Brian mentioned a little bit about the power of these notebooks and what they're able to do. And we go ahead and give every data set a kind of initial tutorial if you need it. That can help you get used to things like adding and querying data, doing things like semantic inferencing, time travel, advanced querying capability, etc. I'm not going to walk through the entirety of the notebook, but I do encourage you to make a free account, as Brian mentioned, and dive in and explore this notebook and others. You'll also see that there's links in the notebook back to the documentation, which can itself also be accessed just through the UI at the upper right-hand corner. And there's plenty of tutorials in here if you'd like to get a more in-depth exploration of what Flurry is and what you're able to start doing when you're working inside of our cloud platform. What I will start to do here, though, as we start to get some data in here that we can work with and see what the platform makes possible, is I'll just use this initial transaction here to add some data for us to work with. You'll see, as Brian mentioned, that all of the data at its core is just JSON. And so we're looking here at a syntax, a query language syntax to insert some data. But the data we're inserting is truly just JSON. When we say JSON-LD, which is JSON for linked data, JSON-LD provides to us through standards that allow for JSON to serialize RDF graph representations of data. They provide us some neat things on top of the JSON, but at its core, it is truly just JSON. And you could drop in data that is absolutely, truly vanilla naive JSON and begin working with that, or you could start to take advantage of some of the things that JSON-LD offers. But either way, you're both adding JSON, you're using a JSON structured query language, and you're getting JSON in your query results as well. The ability to not only understand this as a new user, but also to start immediately building application utility on top of this, hopefully is really, really simple and intuitive, because whether you hate or love JSON, it's likely that you know it. And we find that it continues to be the #1 understood and familiarized syntax for the developer community. Here, we're just going to be adding some data that describes some Yetis and one particular person, myself. Our fascination with Yetis has to do with our mascot, Freddy the Yeti, whose logo you might see around. But I do just want to mention two things that might be unfamiliar to you if you're not familiar with JSON, but they'll pretty clearly make sense if you've ever worked with data before. JSON-LD offers two syntax pieces that we're going to see here, which is the @ID and @type. But @ID effectively just gives a kind of primary key to a JSON entity, because there's no reserved way on a JSON object to say this is an identifier for this particular entity, the way we might be used to a primary key in a table in a SQL database. So here we're just giving a kind of subject identifier to this one entity, Freddy, or to Letty, or to Betty. And the other thing that's going to make sense, but you might not be familiar with, is JSON-LD's reserved keyword @type. And this effectively expresses that this is an instance of a particular class, or if you're used to SQL, it expresses that this is a kind of row in a table. But here we're saying effectively that this is some data about Freddy. He's a Yeti, and that's the kind of class that he's an instance of, or again in SQL, the table that he might be a row in. And the only other person who isn't a Yeti is Andrew. But this is going to be important in a second when we start thinking about permissioning data and putting access policy restrictions around who can see what. But we're just going to go ahead and we're going to transact this piece of data so we have something to work with. And now that we've gotten this successful response here, let's start exploring some of the other things that we can do in our view of this particular data set. So I will mention again that there's several in this notebook. If you want to explore it, you'd have the identical one on any data set you created. And there's several ways that the notebook describes things that you can do when working with the data we just added. But for now, I'm actually just going to go over to our view data screen, which is a pretty straightforward screen that allows you to look at the instances of the different classes that exist so far in your data, and just look at those without having to write or structure a query on your own. So if I select all of our Yetis, I'll effectively get a table view that shows me the data that I just added. It's really just a kind of precursor to glancing at data before structuring maybe more complex analytical queries that actually ask more about the knowledge that your data is capable of expressing. But here we can see we have our 3 Yetis. I can look a little bit. Freddie is a friend with Andrew, and since Andrew isn't a Yeti and he's not on the screen, I can get a quick preview of what that kind of data looks like. I could restrict this down, by the way, as well, if I really only cared about name and nickname, and I didn't care about some of these other columns. It's just a tool for either less technical folks or possibly folks that don't want to take the time to write a query, just to be able to start to explore the data that they have. We can, if we're familiar with writing queries and the kind of JSON, the JSON query language that Flurry uses, express a more direct query ourselves and write that out. And I just want to highlight this because although it's never a fun thing to try to learn a new query language, we like to think that the expression of these, this is effectively based around a W3C standard for graph data, the Sparkle standard for querying graph data, but we've made it simpler by making it into JSON. And the ability to describe something like this, where I'm saying, I want to look for any piece of data that has any entity that has a name value. And then I want to just do a kind of select star on this. So I'm going to wrap this in a JSON map and say for this variable that I've given to the kind of identifier for those entities, just give me select star. It might seem a little bit unfamiliar, but the nice thing is, first of all, it's all JSON. And if you're familiar with just concepts like the JSON you use to add your data, and then things that you might be familiar with, like select star, even in a SQL database, it becomes really easy to start to structure queries that then return JSON data back. We'll see this in a moment too, but if we think about the fact that all of our data is JSON and the query language is JSON too, it becomes really, really easy for an application to start working directly with the data. There's no need for an object relational mapping framework to turn JSON queries into SQL queries. There's no need for even RESTful routes to configure things like data concerns. It becomes very, very easy for an application or client technology to structure a query like this when all of it from head to toe is JSON, and to get JSON back that's immediately useful to that application. We'll talk about this in literally just one sec. I just want to note that there's other utilities available in the UI here that make it possible to explore this data more graphically, like how Freddie is friends with these 3 entities. He's friends with Andrew. Andrew's a type of person with an age of 35, etc. So to explore this data without having to look at it always as JSON when you're inside of the UI. But I just mentioned how easy it is to connect application technology, and I want to just do exactly that right now. We clicked on the documentation link a second ago, and one of the places we'll see in the docs for the cloud platform itself is this section on integrating clients directly with data sets. And I'm going to jump down here because there's actually a stack blitz link that lets us open up a very simple example React app. Let me just go ahead here, compile that app in the browser, and run that app directly against the cloud platform, the Flurry cloud platform we were just looking at. So I will say this right now is reading the same notebook data we just added. This is reading it from a different data set that's structured for read-only access. But I will in 1 second go ahead and switch it over so it's actually integrated directly with this webinar data set that I've just created. I've already mentioned that it's incredibly easy when everything is JSON top to bottom to be able to issue queries programmatically through an application, especially a JavaScript application that of course is going to work with JSON. But we see here that this is almost the query that's being generated here is almost exactly the same thing as what we had just typed into the query editor above. It becomes really easy for front-end developers to be able to just add or extend or make more nuanced or filtered the kinds of queries they want to issue and not have to wait on back-end engineers to extend APIs for those front-end concerns. Obviously, again, there's no need for an API to think about how to specifically shape data back as JSON because the data is from the very top to bottom JSON itself. You might be asking, and I can't see the chat right now, that is one thing that APIs do. Maybe that explains half of what APIs do, but the other half is security, right? How do we make sure that that a query coming in or a request coming in should get the data back that the database would return to it? So let's actually specifically explore that right now. Brian mentioned already that Flurry makes it possible to add data-centric access policy as data, and we can do that. And we can do that through some UI that makes it a little easier to do that if we're not yet quite familiar how Flurry models that data structure for those policies. We do have plenty of documentation that goes into the syntax for that and examples of that, so I encourage you to look at the documentation website. But for now, we're just going to start over here at our policy management UI. So as Brian mentioned, by default, every data set's going to have, including this one that we just made, every data set's going to have a read all group. And we're going to have policies that can be pointed to that read all group. Sorry, but by default, the only policy that we have for that is this read all policy. This is really useful, and a lot of people who want to share access to their data might just use this, right? They don't want anyone to update or mutate their data, but they do want to give people read access to everything that's in there, especially if they're not working with sensitive or trade secret kinds of data. With that said, I want to make this a little more interesting, so we're actually going to edit this policy. We can see that the policy typically gives access to all nodes. I'll change this just so we're being accurate. I'm going to say some nodes. And we see that it specifically is only giving view privilege. If I update this to say modified, then someone who is acting under this policy group would be able to update or insert data. And we see that this policy is applied to the group that I had just pointed out a second ago. Here's what I want to change though. Right now we're saying anyone in this group can read every data from read all the data that exists across all nodes. Let's be a little more specific. We'll keep it read only, but I actually want to change this so that this person can only, or any entity operating within this policy group can only see Yeti data. I do want to mention, although I'm not going to leverage this, you can effectively have sort of cell level permissioning here. And if we had sensitive cells or cells that were specifically PII, we could come in and start not just saying, you can see all rows in this table or row-based access control in this table, but also that you can start doing cell level permissioning, or in this case, just data that exists on particular properties within the graph. Again, for now, I'm just going to go ahead and select Yetis as a whole. So anyone that acts in this policy group can just see Yeti data. I'm going to go ahead and save that. And once it's saved, like Brian shared his data set with me earlier as a collaborator, I'd like to share this data set now, but you do so via an API key. I want the application that we just used over here to connect directly to my new data set. And I want to do it with an API key, but I want that API key to be specifically permissioned. If I go to the settings screen, instead of using the collaborator screen that Brian used a second ago, I'm actually going to go ahead and generate an API key with this read all group. And now back in this application, I'll copy that. And back in this application here, I'll go ahead and update. The README describes this in the application if you find it in our docs. But all you have to do to connect this very simple application to your own data set is give it your own API key and then update the actual, name of the data set that's being queried. So in this case, we saw this on the query editor. I'm just going to grab it from there for simplicity. But this is the kind of machine address for this particular data set. I'll go back here and update it. And we might see this page re-render because it previously was just pulling from a GitHub repo, and now I've kind of forked that repo effectively. But we'll see now that we're connected to my data set. And as previously, with that read all API key that was built into this little example app, we were able to see Andrew and the 3 Yetis. Now we only are able to see these 3 Yetis. So without an API that's doing data shaping or translating RESTful query routes into returned JSON serialized results, we are literally just structuring a query in JSON, sending it directly to the database interface, and getting back JSON data. And although we asked very specifically for any entity with a name, which we already know includes Andrew, we are actually only getting back the entities that pass muster against those data-centric access policies we added to the UI. So in fact, this API key, anyone who's using it, no matter what they ask for, no matter how they structure those queries, and without an API to enforce this kind of logic itself, we're able to see the data defend itself against the policies that exist within the data. And just to demonstrate this again, if I go back to my data set, go back to my policy, and edit it one more time, but this time I want to say, you know what, this person can see not only Yetis, but people. And we save this. We'll see that when we go back to the application, the exact same API key that was previous, without having to provide a new API key or provide a new identity here, but just by simply updating the policy that's in the data itself. And just to kind of prove that point, I haven't shown you that data is here, but I just want to point out that our read all policy is in fact data in the database. We could have used the query editor to write those policies ourselves instead of the managed UI. But with an update to just that policy, if I come back here and refresh the application, maybe I'll do a hard refresh of the site. I did press save and not cancel, right? Let's do a quick check. Oh, sorry, that's the policy group. Let's look again at the policy. Oh, maybe I did click cancel. All right, we're gonna add person to this so it's not just Yetis, but people as well. We're gonna go ahead and save that. And then hopefully as we come back over here, we'll see that this exact same API key. Oh, and let me just confirm that when I refresh that I didn't lose 927. I just wanna make sure that I didn't accidentally, 927, okay, great. We come back and we refresh this. There we go. We see now that, in fact, the policy has been updated for this API key. It includes not only access to Yeti data, but access to people data as well. This gets even, I think, even more fun if we think about actually starting to come in and add some, adding other entity data. For example, I'm going to really quickly rewrite this query so that it's a transaction. And I'm just going to insert a piece of data here directly. Well, let's go ahead and add Brian. We'll recognize him since he was so helpful to start out the presentation here. And we're just going to say, Brian Platts. We know that application is querying for any data that has the term property, but we want to go ahead and query, we want to go ahead and add this entity now and see if that result shows up. We get a response that it was accepted. You might already be guessing this, but in fact, because we've only given the policy group for this access to data of the class person or Yeti, and although Brian has been added with a name, he actually, as yet, that piece of data has, that entity that represents Brian isn't yet an instance of any particular type. And so a policy group that only lets you see data by class and was particular to specific classes would never allow you to actually see that Brian existed, even if you query for the exact property object values that exist on that entity. If we come back here and just go ahead and say, you know what, we'll qualify and make official that Brian Platts is a person, and we submit that transaction. We now have, because and this is just a little, this is mostly a demonstration of the product and of some of the things that you can do around collaboration. If you're familiar with JSON-LD, you'll maybe know that because we have given a unique subject identifier to Brian, even if it's a naive one that's not really qualified as a globally resolvable IRI, because of this, even though it looks like I just did one transaction inserting one entity and the other inserting the other, we did in fact just update Brian here because I've effectively qualified that all of these facts below are true about this particular entity with this IRI. So Flurry would see this not as an insert, but more of an insert or update scenario. Going back now that Brian's a person and refreshing the application, we'll see now that although Brian had a name and fit the constraints of the original query, we couldn't see him because he was not a person. Now that he is a person, we're able to issue the same query with the same API group and the same policy and get Brian back. This is a really, really simple scenario, but what I want to clarify is this. What changed here wasn't an identity. What changed here wasn't a policy group. What changed was the data itself. Because the access policies are articulated as data and are co-resident of the data, the entire context of your data set becomes context for enforcement of access policies. This is a very simple example, but you can actually express very complex data relationships as the kind of evaluation context for whether someone should have access to something or not. Maybe I should only be able to see invoices if I or my organization issued them. But maybe what ends up changing in the data isn't the invoice, but actually I'm added to a new organization. We don't have to give me any other, I have the exact same identity if it's through an API key, the same API key. If it's through a cryptographic signature, then it's the same private key. My query, same API key, suddenly would return many more results because I'm related to an additional organization, and the data state that changed is now the state for context evaluation when I issue the next query. The power of these kinds of things, or another example would be something like entities. You make a policy where entities can see data if that entity has a classification level higher than the classification level of the data. If either my classification level is changed by an administrator, or if the data classification level changes, my access changes without, again, any kind of DB admin or IDP administrator having to change anything about my identity. Or anything about, key signed encryption around packets of data, et cetera. the power and flexibility of letting the data dictate its own self-defense becomes enormously powerful in situations where you want to share and collaborate around that data, and don't want to have to constantly manage identities in order to change data access over a data set like this. So that was just effectively a preview of this ability to use policy, data-centric policy as the enforcement for your data to allow you to directly connect applications to your data, or the third-party clients, to allow multiple producers of data. I could also just as easily have made a modify policy that allows very specific context around who can update what, that allows me to invite other people to enrich or produce additional data into my data set, but on a very granularly provisioned basis. And the same goes for the kind of keys that dictate read permissions. It opens it up to the number of applications that can be operationalized by a single data set, to the number of users that can leverage or take advantage of the data that you're providing them for their own analytics or application capability. This was, again, just a sort of simple way of going through how the policy management UI on the platform enables some of this. But the more that you learn about those kinds of policy relationships through the documentation, the more that you explore the kinds of data that's transacted by itself through the UI, the more that you're able to actually have kind of surgical control and very expressive articulation of the permissions you want to allow in the policy for the data sets that you're sharing or collaborating around with other folks. And maybe this makes a little more sense now if we were to jump back to my data sets and look at the one that Brian shared with me. Brian did effectively a very similar thing that I did. He made it possible for me to query account data, but not invoice data. I now have the ability to directly structure my own queries or to use a notebook that he's given to me. But there is absolutely no way, no matter how I write these queries, and no matter if I were to build an application on top of this, that I could kind of bypass, despite having the ability to directly write and structure queries and transactions. There's no way I can bypass the permissions that are written directly into the data itself. So I'm able to see account data that's relevant to me. I will never be able to see invoice data that's relevant to me unless those permissions around my collaboration were to be changed by Brian or another administrator. There's maybe, I want to wrap up to make sure we have time for questions. There's maybe one other thing I will mention around collaboration that's really powerful. Well, two things. One, this webinar isn't a deep dive into data semantics or into JSON-LD, the powers that come out of inferencing, the ability to describe relationships, not just between your data, but around your kind of vocabulary level terms and definitions, the ability to structure an ontology that can automate reasoning about your data. I just want to show off some of that, though, just to entice you to want to possibly learn more, to tune into our next webinar. An example of that is here in the notebook, where we can start to structure relationships about our vocabulary more so than about the data. So Freddie was a friend of Andrew, and we were able to see a relationship between Freddie and Andrew that we're very familiar to when we're thinking about relational data. But one thing that is really quite impossible when you don't have self-describing or semantic data is to begin to structure relationships and knowledge around the vocabularies themselves. And this quick start guide notebook that comes with every data set, one thing we can do as an example of this is to say that there's a little bit of kind of JSON-LD terminology like context in here that I'll invite you to look at our docs if you want to learn more about what's happening here. But it effectively lets us, what we're seeing in this insert here is that we're able to say things like a class of data called humanoid can be expressed as a parent of, or other classes can be expressed as a subclass of that particular class. In this case, we're saying yetis and persons are both subclasses of a type called humanoid. Why is this interesting? Because if we were to say this, then there's certain things that aren't explicit in our data, but that are implicit or can be automatically inferred. And one of these things would be that we have no data that we've added that describes anything as a humanoid. Andrew was added as a person, Freddie, Letty, and Betty were added as yetis. And yet, if we tell Flurry or express within our graph that yetis and persons are subclasses of a type called humanoid, we're actually able to generate what we think of as just that query time inferencing that allow people to find data by implicit characteristics rather than explicit ones. So if we look at another query here, similar to the ones we've issued previously, if we were being explicit about our data and we said we want to do a select star on all instances of a humanoid, explicitly nothing like that exists. But implicitly, because of that logic, every one of these entities that we added as a Yeti or as a person is in fact a subclass of a human. And if someone was querying that data looking for instances of humanoids, they should find all of those entities. Again, this is some of the kind of enrichment and value that starts to come out when you take JSON, extend it with what's the standards of JSON-LD or of just RDF graphs in general, and start to make it possible to build automated knowledge into the data that you're adding to your data set. I do also just want to mention with the briefest of moments, the value of time travel with data collaboration. I won't go deeply into this here, but if we think about scenarios where we are getting value out of someone else's data set, maybe we are training models on someone else's data that they've given us access to, or we're building analytics or applications on top of it. It's incredibly powerful that we have access to that data at the very same time that we are not the ones in control of that data. We have no idea if that data is going to shift from under our feet. The data set owner or others might be constantly updating that data. And at times it's critical that we don't allow that to happen, or at least that we can audit the state of data as that previously as that data is changing. If I'm training models on a certain moment in time of data, I don't want to lose that data and never be able to return to it to know, to effectively assess the values and power of my models. In Flurry, much like in Git, every addition of data is a kind of immutable commit, and we can always go back to any particular moment of time and data. The way that we index data doesn't allow us just to answer queries. It allows us to understand the kind of time relationship to these immutable commits, such that we can query data at any moment of time, and we effectively, for each of those time slices of the larger data set, we have a fully queryable, immutable data set. If I were, for example, to come down here, and I actually have already updated my data, but I guess I could take a stab. Well, I'll go ahead and I'll do this now. I'll go ahead and update Andrew from being a person to being a Yeti. And I'll come down here now, and I'll query the current data state to understand what Andrew currently is. And if I was working on this data and I had understood Andrew to be a person, it might be tremendously frustrating to me to find that, a minute ago I had issued this query and found that he was a person and not a Yeti, and now he's apparently mutated into a Yeti. In Flurry, we can specify any particular moment of time, and I'm going to look quickly. Okay, that was commit number 9. If commit number 9, Andrew is a Yeti, then at commit number 8, I can go back and find that Andrew, at this point in time when I care about the data being locked in and immutable, Andrew remains and always will remain to be a person. I've expressed this in terms of a commit number, but it just as easily I could have used an ISO string to represent a date time and could have queried data like that as well. When we think about the idea of sharing our data with others, if they don't want to constantly have to update their own knowledge of the analytics that they're generating based on your constantly shifting data, and they want this power of immutability so as not to be kind of left in the wash as a data set provider is changing that data constantly, this guarantee of immutability and a queryability of every immutable moment of data becomes incredibly powerful in this kind of ecosystem of data set sharing. Again, this was just a very brief touch on that and the power of that in collaboration. Our documentation explains a lot more of what you're able to do with kind of audits and time travels around queries. So if this is at all exciting to you, I encourage you to start a free account and to look for more information within that those documentation. And with that, I'm maybe 1 minute over what I was hoping to be, but let's switch over now to some question and answer if there's any that's waiting for us.
Thank you, Andrew. Yeah, so we have a very engaged live audience today. So thank you all for many of your questions. And I see Brian has been going through some of them and answering them live. I'm going to choose a few. I know we only have 9 minutes, so we'll try to get through these pretty quickly. Jell asks, is there support for delegation chains? For example, person A has created the database, person B gets read and write access to entity type A and B. In the case of a delegation chain, person B would be able to give the rights to what it can do to yet another person if allowed.
Well, I'm happy to take that. Sort of, I wouldn't describe it exactly in the way that you did it here, but there was another question that I had already asked that I gave an answer that addresses this to some degree, which is the policies themselves are literally just data. We've had so many questions. I've been answering them the whole time. I actually haven't heard everything that Andrew's gone through, but if he's talked about shackle and shape constraints, those of course are just described as additional data. So everything is data, and therefore, since policies govern data, it means that a policy can actually govern a policy. So you can actually establish things where you can say, here's sort of baseline policy in the organization, and this is exactly who and under what conditions can actually modify or create policy. So you can get that delegation sort of effect. I would say it's, slightly more sophisticated, obviously, because you're creating policies that govern how and who can create policies. But what you describe here should be fully supportable, just slightly differently than how you asked the question.
I think you answered a few of these questions, Brian, but I think they're good for the general group. Alan asked a few questions on access policies as well. Can access policies govern specific fields and properties on an entity set, for example, to hide PII information? And then related, can policies be placed on the update values being put onto an entity? For example, only an admin could set another user's role to admin.
Yeah. So I did answer those in text if anyone saw them. But a really exciting capability, of course, we're a graph database, and being a graph and having policies that can be enforced as data inside the graph means that we can actually leverage the graph as a way of enforcing policy. And this is a type of security policy there's very little tools that actually do this today. It's more in research, you're going to find it, but it's generally called RBAC. So we have RBAC, role-based access control, ABAC, access-based access control, which a lot of people are going to. And of course, both of those paradigms can absolutely be enforced in Flurry. But then Flurry also has this other way of enforcing policy that's just so powerful called RBAC, relationship-based access control, where relationships in the data can actually govern exactly what you can see. So every sort of user has an identity. That identity can be an entity in the database. And if that identity is linked to data in some way, you can easily set a policy that says the user can see it. So in the case of PII, you could quite simply actually put in a rule and say, by default, no one can see any PII. You can define what those fields are. You can attach them to a class. You can attach them to just properties. However you want to sort of describe that policy, we give you a few ways of doing that. But you can say nobody can see this field. But if the person trying to see the PII is directly connected to the PII through some relationship, maybe through a user relationship or an employee relationship, or through a manager or supervisor or human resources relationship into that user, it becomes available. And then when you say select star from social security number or whatever the PII is, you'll see almost nothing, except for if you're connected to the data, because that policy enabled it through the relationships. If your own social security number, you see it. Or if you're part of the HR team that's connected to that individual, it shows up for those individuals for you. Or maybe there's a relationship that uses the hierarchy in relationships in the data, like the manager, managers, manager, managers, 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 et cetera, all the way up. Recursively, they can see it. It'll show up for them. So, I think once you sort of start thinking about using relationships in the data to enforce security, you end up pretty quickly in a situation where you realize trying to enforce complex rules were either almost impossible or might require you to create, 3,000 roles, and try and assign them to different people. And here, a simple rule can leverage the data and actually express that complexity very simply. So, really exciting capability there.
Great, thank you. Raymond asks a great question. Do we have to create all data sets on the Flurry cloud or on local machines as well? I think we have a really interesting answer to that, Brian.
Yeah, so the Flurry core technology is open source, and the cloud version is just us running our own open source technology, so you don't have to spin up your own servers and do those things. So you can absolutely just run it locally. You can point right now the native system, we have pluggable storage. We do have pluggable support today for local file system. Of course, that's about the only thing most databases will do. You can put it in an S3 bucket. You use S3, as storage. There's a small performance hit when you do that because S3 is a little bit slower than writing to local disk. We support IPFS. So if you want to, really get into the decentralized world and use the interplanetary file system, you can actually store and manage your data there, and then people can load up, their graphs or databases across the decentralized network. So there's a lot of different storage options. You can run your own server, figure out how you want to store it, where you want to store it. The important thing is that the query server is the thing that actually answers query. It caches data from these ledgers and memory. So you're usually running queries at in-memory speeds. That query server can aggregate data across any data set it can see. If it's private behind your firewall, if the query server is behind your firewall and you're behind your firewall, then the query server can see that data. But then it can probably also see data in the Flurry cloud, right, on Nexus, that may or may not be your data, but you might want to merge it in with your data set and execute a query. So, the query server is really what's executing the queries. It's running at really in-memory speeds. And anything that it can see, it can aggregate together. So, you can run it on your own, and then wherever you want to run a query server, you can do it. Now, Nexus itself is a gigantic query server, which is cool. But if you've deployed, obviously, a Flurry instance behind your firewall, Nexus as a query server the Flurry cloud as a query server cannot actually get behind your firewall. So if you tried to aggregate that data in a query, it can't get to it. So it wouldn't be available. But hopefully that describes a little bit how it works.
Yep, that's perfect. I think we have 1 more minute, so we have time for one more question. And Andrew, I know that you're replying to Domenico, perhaps, but I think it's a great question, so I'll ask it here. How multiple government roles and policies play out? I assume government roles and policies play out when applied to a user, especially when they might conflict. One might succeed while the other fails.
Yeah, and I was typing a response to Domenico, so I'm sorry, but you'll get it now. Yeah, in short, and with a lot of thought, the general behavior of how this works is a kind of logical OR. And we think of this as, here's a basic example that makes sense of why we've chosen that. But if you think of, it's very common for people to have be members of multiple policy groups. I might be a student at an institution, but maybe I've also been assigned as an admin at that institution, or maybe, I don't know, a resident advisor, since I mentioned student. And maybe a student policy group would fail or wouldn't pass muster on a particular query to let me see a particular piece of data I've asked for. But the admin policy group does in fact allow for that. It's fairly obvious in scenarios like that we want a kind of logical OR behavior, so that if you're members of multiple policy groups, that those policy groups are applied where only one has to succeed for you to have access. It is with that said, there's a kind of syntax that you can use in policies to express and conditions. I do think we are maybe have a paucity of documentation on some of the more granular ways to shift that particular dynamic from a kind of logical OR to a logical AND. But as a default, they work in that scenario, because we find that the vast majority of scenarios where people would have multiple conflicting or overlapping policies, they would want for the more empowered policy to trump the less empowered policy.
Awesome, thank you. So thank you, everybody. This concludes our webinar.